Writing ionic compounds is all about making sure that the total amount of positive charge contained in any compound is equal to the total amount of negative charge contained in any compound. Even though the individual ions have charges, the overall compound has a neutral charge. So what we do when we're trying to make an ionic compound is we first have to see what the charges are on the ions. In this case, we're number 6. Calcium has a 2+ charge. It's in group 2A. And fluorine, or the fluoride ion, has a -1 charge. It's in group 7A. To make a compound between calcium and fluorine, which remember is ionic because we have a metal and a nonmetal here, we have to make sure the total amount of positive charge, our 2, is equal to the total amount of negative charge. Now, in this case, it's pretty clear that we're going to need 2 different fluorines, because if we have 2 positives and then 2 individual negatives, the total positive charge is 2+, and the total negative charge is 2-, giving us a net charge of 0, which is exactly what we're looking for. Now, you could do this using 2 negative charges, like we'll see in this example, or you could do this using one single ion that had a charge of 2-. Either way, all that matters is the total amount of charge involved on the positives and the negatives, and making sure that together they make that 0. So let's go through how this works. Like we said, calcium has 2+, fluorine has 1-. Since it takes 2 fluorines to equal our calcium, our final formula will have 1 calcium and 2 fluorines. This gives us our 2+ and our 2-, giving us a total net charge of 0. Let's go ahead and get that out of the way so we can see what we're doing with the rest of them right here. For number 7, it works the same way. Lithium is in group 1A, so it has a +1 charge. Nitrogen is, see here, that's a 3- charge right there. Clearly, just like the first one, we're going to have to multiply one of these, the lithium, to be equal to the other one, the nitrogen. However, there's an easier way of doing this. Really what we're doing is we're making sure that we have a common multiplier. Both 1 and 3 can be multiplied by something to equal 3. But there's a way that you can make a little shortcut, kind of make your life easier, and instead take all the thought out of it. You're still doing the math, but you've removed it from your conscious thought. Instead now, what we're going to do is something I call the switcheroo. We take each charge and bring it down to the corresponding spot on the opposite element. We're going to need 3 total lithiums, because 3 times our +1 equals 3+. And we're going to need 1 total nitrogen, because 1 times -3 equals 3-, and 3- and 3+ equals 0. That's what we want to do. But instead of going through all that, what we're going to do instead, here, let me replace that up above. Put the charges there so we can look at it later. What we're going to do instead is just, instead of thinking about it, move this down here and move this down there, giving us Li3N. Where the 3 that we see down here, here's our 3, is from this 3 over here, the one that was on the nitrogen. Now, let's try it with a polyatomic ion. Polyatomic ions work the same way. They may look differently, but we're still just trying to balance out the charges. So barium is in group 2A. It's got a 2+ charge. Carbonate, hopefully you remember, has a 2- charge on it. So these two are already equal to each other. We don't have to do anything particularly special there. Since they already cancel out, we don't have to multiply anything, and we get just BaCO3. Now down on the next one, where we have aluminum, aluminum is a 3+ charge. Sulfate does not match aluminum. It's got a 2- charge. Now, 3 and 2 are a little more challenging than things we've done so far, because neither 3 nor 2 can go into the other one. Both of these would be joined together to give us 6 as the common multiplier we have to get to. Now, we could do the math and look at this and say, okay, our aluminum is +3, so we're going to need 2 of those. to equal 6. Our sulfate is -2, so we're going to need 3 of those to equal 6. Or we could just do the switcheroo and take these down to where they go, giving us Al2SO4. Now we need 3 sulfates here, but if I just wrote a 3 there, it would look like SO43, which is a little bit ludicrous. Way too big. So instead we just use some parentheses to separate that 3 out from the rest of the compound. There's our 3 sulfates. Reviewing this one last time for magnesium. Magnesium is a group 2 metal, so it's got a 2+ charge. Nitrate is -1. Now you could either think about it like 2 of these is going to equal 1 of these over here, or you could use our shortcut and do the switcheroo where the 2 comes down here and the 1 goes over there, giving us Mg, and then no number because we don't write ones, and we have 2 NO3s. So remember, we don't want to just write a 2, that's NO32, and that's crazy. So instead we use parentheses to separate the nitrate out from the number of nitrates that we have. And that's how you write an ionic compound. Remember though, don't always assume that you're going to use parentheses like this. In our barium carbonate, there's only 1 polyatomic, so there's no numbers to confuse us. So we simply write the formula as written, BaCO3.